Now that we have a starting script for the gym manager and some gym prefabs, we can put them together to create a grid of gyms. The first thing we'll need to do is add a field to our gym manager class that will store a reference to one of the prefabs we made. In general, it's a convention to have all your fields above all your methods in the code for quick and easy access. To do that, add the following code inside the class after the opening curly bracket but before the start method. Public GameObject gym prefab. Recap from the previous video, variables first have the access type, public or private, then the type of data we want to store, GameObject, and finally the name of the variable, gym prefab. Since declaring that a variable exists as a statement, we need a semicolon as well. Now if you look at the gym manager in the inspector, you should see a new input field appear on our gym manager component. Similar to selecting a sprite, you can click the dot and circle icon to open up a search window and look for the game object you want to set as the gem prefab. There are two tabs, Assets and Scene. The Assets tab shows all game objects stored in the Assets folder, which would be our prefabs. The Scene tab just shows any game object instances in the actual scene, which is just our camera, light, and gym manager for now. You can also drag an asset from the project window into the input, or in this case, drag one of the gem prefabs. Once you set the prefab to use, our gem manager can take that prefab and make gems by duplicating it and putting that copy into the scene. Back in VS Code, add the following line inside the start method between the curly brackets. Instantiate gem prefab. Mono behaviors, or any class based on that class like our gem manager, have an instantiate method, which allows you to create a new game object in the scene based on the template or prefab that you give it. In this case, we are telling the gem manager to create an instance of, or instantiate, the gem prefab when the game starts. Going back to Unity, you can hit the play button at the top middle. It may take a few seconds to load, but once it does, you should see the gem we created appear. Press the stop button to exit play mode. Before continuing with instantiating a grid of gems, I want to call back to the previous video where I talked about variable accessibility. We won't need to know about the gem prefabs in any class other than gem manager, so let's make the gem prefab field private. As a convention, private field names start with an underscore to quickly show which variables are private when you are using them later in the code. If you go back to Unity, you'll see that the gem prefab field no longer appears in the inspector. By default, any private field won't show in the inspector, so we need some way to tell Unity to show it anyway. That's where attributes and serialize field come in. Attributes are used to describe a field like its minimum value, a range of acceptable values, a tooltip in the inspector, etc. They can be very useful, but I won't list them all here. Instead, I'll challenge you to look them up as practice for researching game development, which is very important. To add an attribute to a field, place the name of the attribute in square brackets before a field. Some attributes also take inputs like a function does, but we won't need those for now. Add the serialize field attribute, which shows private fields in the Unity inspector. Now you should see the gem prefab field in the inspector again, but you'll have to reassign the prefab you want by selecting it again or dragging and dropping it in. Whenever a field is no longer visible in the inspector, Unity deletes its data because it isn't needed anymore. If you rename a field, the same thing will happen, so make sure to reassign and re-enter any data if you change the field's name. Side note, there may be another attribute you can use to prevent this. I encourage you to research that as well. Click the play button again after selecting a prefab to make sure it still works. Finally, we can create a grid of gems. For now, we will just create a 2x2 grid manually and with the same type of gem in every spot. In a later video, I'll teach you a better approach. For now, however, we will manually instantiate and position the gems one by one. First, we'll need to store a reference to each gem we create. GameObject gem1 equals instantiate gem prefab. Note that we are creating a new variable inside the start method. This isn't a field since it doesn't belong to the class. This variable is only accessible inside the start method because we define it there, and only in the lines of code after we define it. Therefore, it's called a local variable because it's local to that method. Just like any other variable, it needs a type and then a name. We can just declare a variable saying it exists by declaring its type and name, but in this case, we also want to initialize it by setting its starting value. To initialize a variable, you can add an equals sign after the name, and then whatever you want the value to be. In this case, the instantiate method returns the newly created gem. That's the game object we want to store in our new variable. Now that we have a reference to the gem, we can position it in the grid. Remember from a previous video that a transform contains the position of a game object. Game objects have a transform field that stores a reference to its transform component. From there, we can modify the position similar to how we initialized a variable's value. On the left side, we give the variable name, and on the right side, we give the value to assign to the variable. Also remember in the previous video how the position of a game object has a value on the x-axis, on the y-axis, and on the z-axis. However, we will only need the x and y coordinates for a 2D game where z is usually 0. We'll ignore the z-axis because it's only needed for 3D games. Unity has a class called vector3, which is used to store 3D vectors. Vectors have a length and a direction represented by a value in each dimension, x, y, and z. Instantiate is used to create a new instance of a game object based on a prefab, but when creating a new instance of a non-mono behavior class, we can just say new, the class name, and any inputs. In this case, this is a new vector3 instance with an x position of -1, a y position of -1, and a z position of 0. To save space, we can also just give it an x and y position. It will assume a z position of 0 because z is an optional input or parameter. Notice you can use the up and down arrows when the autofill menu pops up to see these two ways of creating a new vector3 instance. Sometimes other methods you call will have multiple ways of calling it using optional parameters that you can see in the autofill menu as well. Now let's create 3 more gems at the following positions: -1, 1, 1, -1, and 1, 1. This is rather inefficient, but it will work for now. In future videos, we will cover how to improve this, starting with a better way to keep track of our gems and easily instantiate many gems of different kinds with only a few lines of code. Until then, God bless and keep up the good work. You've been learning a lot so far, and we're so proud.